This is Greg Troutline with Maritime Reporter TV, and we're very pleased to be joined today by Asbjørn Halsebakke of The Switch to discuss the company's new generation, the Switch DC Hub, and its unique electronic DC breaker, EDCB, and electronic bus link, EBL. Asbjørn, it's really nice to have you back on Maritime Reporter TV. And while the Switch needs no introduction to this audience, to start, can you give us a by the numbers look at the Switch today?
Well, thank you for having me, Greg. It's always nice to have these talks with you. I find them very interesting. Well, the Switch, we are a product supplier, and our full name is Jaskov Environmental Energy / the Switch, but we are fine with using the Switch. We are a product supplier, supplying drives for marine and wind and also industry, and also permanent magnet machines for marine, wind, and machines also for industry, for high-speed machines. But my focus is marine. That's where I've been working now for more than 20 years. Very happy to be in that area. And drives is my area of expertise and what I'm normally working with. So very happy that you had the opportunity to let me speak a bit more about our EBL, or electronic bus link, and our EDCB, electronic DC breaker.
You know, as I noted in my introduction, the Switch is starting to talk about its new generation DC Hub. Can you give an overview of this product evolution with insight on what you believe makes it unique for the maritime space?
I think one of the key features with maritime products and with DC Hub is that you need to think about personal safety. You need to think about how to make sure that everything is in a safe mode, and if you have a critical fault, you need to disconnect that. And that is what we are able to do with our EBL and EDCB. With the electronic DC breaker EDCB, we can disconnect a module within 10 microseconds, and that is faster than any fuse, faster than any breakers. And by doing that, we make sure that we have the redundancy, we have the ride-through of the complete system. Because everybody of us that has been on board the vessel, we know that one of the scariest things are when you don't have the noise of a diesel engine or of an engine, and everything goes black. That is really scary. So we need to avoid that by all means. And by using our electronic DC breaker, one fault will disconnect only that fault, and that's it. So you can continue to run. You will continue to have your main propulsion running, to have your tunnel thrusters running, to have your winches running, and everything is good to go. But you can still have one critical fault on your main DC link, and that is a difficult one. Then you will lose that DC hub, but you can then have another DC hub. You might have a 2-split, 3-split, 4-split, whatever, depending on the solution. And the EBL, electronic bus link, will then disconnect that DC hub and only that DC hub. Or if you, for some reason, have a short circuit on the cable between the different DC hubs, we will disconnect that. And that, again, we are doing in 10 microseconds. We are using our expertise in IGBTs, in power electronics, and in controlling them. And by using that expertise, we can then we have developed something that is then much faster than any fuse, and make sure that you have the selectivity, you have the ride-through, and you don't go into any critical situations, because that's a scary thing.
So in practical terms, what operational or life cycle benefits does the EDCB and the EBL offer to the end user?
Well, to the end user, it is much easier installation, because if you have a fault or an overcurrent, you don't have to go down and change a fuse. You can just press reset on the bridge, try again. If it's not a critical fault, you're up and running. There's no problem with that. But what is very important with our EBL, it gives the possibility to introduce a new DC hub. Because when I speak with ship owners today, they say that one of the things that they are quite aware of, and things that they are really know will happen in the lifetime of a vessel that is being built today, the energy sources have to change. It has to do that. Are we going to meet the goals that are being set by the government, by international regulations? We have to change something. And then, but are we really sure what it will be? Do we understand today that the new energy source will be hydrogen, it will be synthetic LNG, it will be ammonia? I think that is very difficult to say. So by having our EBL in a DC hub, we can connect a new DC hub into the system that then might have the energy source that will come in 5, 10, 15 years time. That might be a fuel cell. It might be a new engine that you would like to have on board, and might be something that we are not discussing even today, because things are moving so fast forward that I think it's very difficult to say that, hey, this is a solution in 10 years. I don't think we can do that. So I do believe that we have to be future flexible. We have to be able to be able to handle changes that will come. And with our solutions, that is possible.
Does the Switch's new generation DC hub offering have any real world installation references that you can share?
Yeah, we have the first installation we did was on a vessel called Hagland Captain. We did that commissioning actually during one of the really bad COVID periods here in Europe during this summer. So we had to do a lot of the commissioning over phone. We had to do remote setup with our computers connected, but it worked quite fine. And when I talked to the guys that are on board the vessel and the owner, they are very happy about this installation. It's working very good for them. And we have 6 more vessels just coming up. We have delivered 2, not put into two solutions, DC hub solutions. They have not been put into operation yet. We haven't done the commissioning, but that will happen during this spring. So we're very much looking forward to that. It's vessel that we normally haven't been seeing so much hybrid installations for, but I'm very happy that these owners, Hagland, and the owners for the others, Misha Shipping, are really looking into these possibilities with a hybrid solution and with a DC hub, and can see the benefits.
I know that the market for hybrid electric solutions is broadening rapidly, but when you look at the world today, where do you see the best prospects for this solution by vessel type?
It has been a quite fast development of DC hubs, and today almost all our offerings and all our deliveries are with a DC hub. I do believe that most vessels can benefit from having a DC hub on board. I don't believe that all vessels should have a complete DC system. There are vessels today where it's better to have a mix of an AC and a DC system, but the more energy source you have on batteries, on fuel cells, on variable speed engines, the better it is to have it on a DC hub. So quite many vessels, and we are seeing new interest for vessels that are being developed today. Even new Navy vessels we can see are coming into the DC hub configuration. And we are very happy to see that it's all over, from tankers to fast passenger ferries to well, also reefers are going into some sort of DC hub solution. And we believe that this makes everything a lot easier for the vessel owner, for everybody to reach the goals that IMO are setting for us, and to be a more environmentally friendly solution on the vessels.